Now, on to part B then. So this could be part B or part C of a question. Alright, so in this case here, this is what part B is. It's worth 16 marks out of the 60. And in this case then it's worth 26.6 or 27%. Alright, so it's worth a nice bit as well. Okay, so there's a little bit of thinking in it. Alright, so what you find is part A is in most exams is fine, and part B gets a little bit harder, and then part C gets a little bit harder as well. Okay, so that's the same with construction. So part B then is proposed to convert the flat roof to an inverted warm deck by adding rigid foam insulation over the asphalt. Right, so you have two types of flat roof. You have a warm deck and a cold deck. So insulation on the outside is warm, insulation on the inside is cold deck. It's hoped to achieve a U value of 0.16. Given the information below, calculate the amount of insulation to be added to achieve the desired U value. Right, so the only information then you're given is the U value of 0.16, and then the conductivity of the rigid insulation foam is 0.023. Okay, so we have to work a little bit in reverse. Okay, so when we had our U value here, we divided 1 by total resistance to get the U value. Okay, so in this case, in this question, or in this part, we're given our new U value. Okay, so new U value, in this case they want it to be 0.16. Okay, so we need to find the total resistance then that this has to put up to get to that. Okay, that has to be added on to get to that value. Okay, so the resistance then, right, so that's found by dividing 1 by 0.16. Alright, so if you work a little bit in reverse, so 1 divided by 0.16 gives you 6.25. Okay, so 6.25. That's the total resistance. So when you get to the very bottom of that calculation there, the total resistance needs to be 6.25. Right, you already have 0.7604. You already have that from the makeup of the roof so far. Okay, so that's already there. That's the total you need to get to achieve this. Okay, so then this needs to be taken out of that. Okay, so that needs to be factored outside of this to get the more accurate representation of this. Okay, so this has to be new resistance minus old. Okay, so new resistance 6.25 minus 0.7604. Okay, so what does that give us? 6.25 minus 0.7604. So that gives me a total resistance of 5.4896. Right, so that would have to be, if we were to put in a new layer here now, and say we put in external insulation, right? So we were given our conductivity value, so we'll add that in a second. We weren't given resistance. We're trying to find this thickness value, and then we have the end value, right? So that's the end value now. If we were to do it normally, that 5.4896 would be what would be in this column over here. Okay, so that figure there is fairly important. Okay, so what have I done here? I've done one division, right? So divided 1 by 0.16 to find 6.25. That's the required. We're taking away what we already have, so we already have that resistance, right? So that's how much force we have there to stop the heat from escaping, and we're trying to achieve that, right? Which is a massive jump from there, isn't it? Okay, so and then you have to think, like, when I'm saying a massive jump, that's the original U value, that's what we're trying to achieve. Okay, so it is a huge jump, alright? So obviously that total resistance was going to be high enough. Okay, so then I suppose just trying to keep it in the format that we have here. I'm going to do the same thing again. So I'm going to go layer, conductivity, resistivity thickness and resistance. Alright, just to try and keep it looking similar. Alright, so previous methods that I might have done for the likes of this might have been slightly confusing. Alright, so maybe this might help. So sticking with what we had. Okay, so layer, so we're going to say external insulation. Okay, so then we're going to go back to the question. Right, so the question asked, or not the question asked, the question told us the conductivity of this was 0.023. Right, so we put in our K there, we have our small r as well, thickness, and then resistance is big R, let's put it there, we have space. Okay, so that's what we're told. Okay, so we'll fill in any other information that we have then. We don't have the resistivity, and we're not trying to find it. Okay, so don't get bogged down on that. Resistance then, we have the finished, so we have 5.4896. So we have that. Okay, so we're trying to find the thickness here. Okay, so normally what we would do, we have our formulas. Alright, so we have resistance is equal to resistivity by thickness. Alright, and then the formula that we crossed out earlier, we have resistance is equal to thickness over conductivity. Okay, so we're going to look at that formula now. So we're going to say R is equal to T over K. Okay, so that's not going to help us too much. Okay, so then we need to look at a way of being able to calculate this. So if you were working in maths, you would multiply, you're trying to get rid of the fraction on this side. Okay, so if you're trying to get rid of the fraction on this side, you would multiply this side by conductivity, which means you would have to multiply the other side by conductivity to keep things in balance. Okay, so that's what we're going to have to do here. So if we multiply resistance by conductivity, we multiply this side by conductivity, we cancel out our K underneath the T. Okay, so this becomes thickness is equal to conductivity by resistance. Okay, so I know it's in letters, alright, so it's slightly different than what you do in maths or what you see, but if you're trying to get rid of a fraction, you multiply both sides by what's underneath. Okay, now there's no fraction over here, but you're still multiplying that side. Okay, so you multiply that side and this side, so the K disappears, that's why you end up with thickness, and then you end up with resistance multiplied by conductivity. Okay, which is what information we have. Okay, so now we'll just fill in what we have. So I'm going to say 0.023 multiplied by 5.4896 equals, okay, so 0.023 multiplied by 5.4896, okay, which gives me 0.126, and remember that's meters. Okay, so then if we're just writing mil, so then thickness required equals, alright, so if we're to work in just work in reverse, okay, we're going to have to multiply this. We're going to have to change this back to millimeters. Okay, so moving that decimal place back 3 places. Okay, so it's going to become 126 millimeters in this case. All right, so how long are we at this now? 9 minutes. All right, so there's a little bit of thinking in it. All right, so a small bit, just where the 16 marks then are spread out. Okay, to get this 6.25, got you 4. Okay, so just by doing that division there, got you 4 marks. Doing this subtraction, got you 4 marks as well. Okay, so to find that, got you 4 marks. The only reason I'm drawing out this table here is to try and keep it something similar to up at the top. Right, so that's the format that you're used to, or I think you're used to. So that's why I drew this out here. To work and try and figure out how that formula should appear. Okay, so to work how that formula should appear, that gets you 4 marks for that formula, and then putting it through the formula and getting 126 mil got you the other 4 marks. Okay, alright, so I suppose one other way that I would look at working with that formula, or any of them really, okay, so particular that one, because it's in the question here, I would draw out a triangle like this. Okay, I draw out something like this. You may have seen me do this before. So here T is at the top, and then I have R and K at the bottom. Okay, so if T is on top, if we're to find conductivity, T is divided by R. If we're to find resistivity, resistance, if we're trying to find resistance, T is divided by K, alright, which was the formula we start off with, alright. So then, the way I would go about it then is I'd try and cover up. So if I wanted to find resistance, I'd cover R with my finger, T is divided by K. If I wanted to find thickness in this case, which I want to do, I cover with my thumb here, R multiplied by K, right? So they're on the same line, so they're multiplied this time. It's not one over the other, so they're beside each other, so I multiply them, alright? So that's one approach that I might take to figuring out what way that formula should be, okay?